In this video, we're going to have a look at the theory behind tides. What causes tides? What are spring tides? What are neap tides? And how we can find that information out in the almanac. So let's take a look at some tidal facts. The moon is the main reason for tides around the world, due to the fact that it's closer to the Earth than the Sun. The Sun is the second biggest factor, due to its size. The moon and the sun combine to pull the water around the surface of the earth, giving us tides. Given that the earth is constantly rotating and the moon is constantly going around the earth, and both are orbiting the sun, mean that the pull from the moon and the sun changes. The result of this is we get different tides, which we refer to as springs and neaps. Because the moon takes just over 29.5 days to orbit the Earth, the lunar cycle, it means that every 7 days the tide around the world changes from springs to neaps. In the UK on average we have 2 high tides and 2 low tides a day, with the difference being just over 6 hours. There are a few anomalies to this, but the 2 high tides and 2 low tides a day are the average. There are 3 key definitions. Spring tide is what we refer to as the highest high tide and lowest low tide, and occurs when the sun, moon and earth are in line with each other. Neap tides are the lowest high and the highest low, and occur when the moon is at right angles to the earth and sun. The range of tide is the difference between high water and low water, and it's this number that we use to work out reasonably accurately whether we are in springs or neaps. So looking at this diagram here, just expanding on what we were talking about a minute ago, we can see that the sun, the moon and the earth are all in line with each other. And we can see here where my cursor is that we've got a huge pool of water getting pulled one way. But due to physics, it also gets pushed the other way. This causes spring tides because all 3 are in line. We get the highest high tide on one side, the other highest high tide over here, and 2 spring low tides, the lowest low. 7 days later, the first quarter, this is the first of our 2 neap tides. And as you can see, the image of the water around the earth is a lot more even. 7 days later, and we're back to our second spring tide. The moon, the earth and the sun are all in line, therefore giving us our 2 large spring tides. 7 days later, we are back to our second neap tide of the month. And then it all starts again with our spring tide. So this is how it looks in the almanac. This is an extract from the RYA Training Almanac. And we can see in the bottom right hand corner that we have the mean ranges. So this is the spring range and the neap range on average. 4.9 meters for springs, 2.4 meters for neaps. We can also see that close to the 3rd and the 18th approximately, and the 1st and the 16th over here in September, October, those dates are highlighted in blue. Those are neap tides. We can see the 12th and the 26th and the 13th and the 25th, etc. in red. These are the spring tides. By far a better way to test it is to look at the range of tide. It's more accurate. So if we pick the 26th, we can see it's colour-coded red, but the range of tide, difference between low tide and high tide, 0.6 and 5.7. That's 5.1 metre range. That's 0.2 bigger than the spring range over here of 4.9, the spring average range. So we've got a larger than usual spring tide. Picking one up here on the 2nd, it looks as if we're on neap tides because it's blue. The range between the first high tide in the morning and the second tide is 2.5 metres, just slightly above neaps. And as a third example here, it says it's blue, so that would lead you to think we're on neap tides. But if we take the range here, we've got a 3.8 metre range of tide and a 3.5 metre range of tide here, which puts us on a mid-tide. So the neap is too small and the spring is too big. So it's well worth working out the range of tide on the day in question. So one last thing to have a look at. So what can cause a difference in the depth of water? It's not just height of tide and springs versus neaps. This example in the top corner is a southwesterly wind, and Helensburgh, Brew, the Gairloch is right at the top of the River Clyde. So we're kind of insinuating that there's an incoming tide, a big southwesterly wind, and the water gets pushed all the way up into the top corner, and it really has nowhere to go other than up. The weather also has a very significant factor. High pressure pushes down on the sea state or the sea level, and that red dotted line insinuates that there'll be much less water over a high pressure than there will on a low pressure. So low pressure pulls the sea state up. As a rule of thumb, for every 10 millibars difference from 1013, which is the average atmospheric pressure, the sea state rises or falls by 0.1 meters.